Hello and welcome to the Car Care Nut channel. In today's video, we're going to continue on my series on how Toyota engine controls work. In today's video, we're going to cover engine starting, including the most important sensors, the crankshaft position sensor and the camshaft position sensor. Also, we're going to start with what makes the gasoline engine run and how it's controlled, starting with air control. But before we get started, if you're new to the channel, welcome. Consider subscribing to the channel. Check out some of my other videos. If you are a returning subscriber, thank you so much for watching another one of my videos. And without further ado, let's dig right into it. So the cam and crank position sensors. So in the previous video, in the previous part of this series, we've talked about the gasoline engine, how there are 4 strokes to the gasoline engine. Now, when we had carburetors and even when we had distributors, things were a lot simpler because you had mechanical parts connected to the engine. But in modern cars, the computer needs to know where the mechanical parts are. That's why all these sensors, there's a lot of sensors that all they do is just connect the mechanical parts to the computer brain, so the computer can see. Remember, computers, they need to see what's going on so they know how to control everything. So the most important thing for a computer to know is which position is the mechanical parts of the engine are at. For example, where is the cylinder number 1? When does it hit top dead center? Which stroke is the engine is at? Remember, you're driving your car and then you shut it off. Well, where did this engine stop? That's what the computer needs to know. Yeah, some people will say, well, why doesn't it store that? But remember, when you shut it off, the computer just stops. Okay, just cuts everything and lets it go. Wherever the momentum of the engine stops it, it stops it. So the computer needs to know, when you first start the car, needs to know 2 things in order to know how to start this engine. It needs to know where the piston is at. More importantly, piston number 1, when does it go to top dead center, or when does piston 1 go all the way at the top? And then the second thing it needs to know, where is the camshaft location is at? Because remember, when the piston is all the way up, it could be at the end of the exhaust stroke or the beginning of the intake stroke, or it could be at the end of the compression stroke, the beginning of the power stroke. So the computer needs to know this in order to know, okay, when am I going to start doing all my other operations and actually get this engine running? So in order to do that, there is a lot of misconceptions about the crankshaft and camshaft position sensors. And we're talking exclusively about Toyota here. Being a Toyota owner, you're not really going to deal with those a lot because it's no secret, they don't go out a lot. But let's talk about them and talk how important they are, because this will help you a lot in understanding why there's a lot of misdiagnosis about them. Let's talk about, now what I have in my hand is a cam sensor. Now the crank sensor looks similar, a little bit different operation on the inside, but they're very similar in their operation. This is essentially just a pickup coil. It has a magnet, here's a piece of metal, there's a magnet here, and somewhere on the engine there is a wheel that looks like this. It has teeth, and then you notice at some point it's going to have a flat spot. Now this flat spot is very important, but let's talk about how the sensor works, and then you'll see why this flat spot is important. As these teeth pass in front of this sensor, now they sit at a certain distance. Every time the high teeth passes in front of the sensor, it creates a signal. When the empty spot passes, it creates a different signal. So when you look at the signal, now this is connected to the crankshaft and is turning with the engine all the time. And this guy is just sitting watching. As this wheel turns in front of this magnetic sensor, it's going to create a pulse. The voltage that's going to the sensor is going to start getting changed. It's going to pulse. Now that pulse, the computer will read. Now the flat spot is top dead center. So the computer is going to, okay, now I am at cylinder number 1, top dead center, and it's going to start counting. 1, 2, 3, 4, 5, 6, 7. It's going to count until we reach the other again. Cylinder number 1 have went up again. Now this is 1 revolution of the engine. This is how the engine knows the RPM. This is how it counts the RPM. So it's counting cylinder number 1. Let's start counting. 1, 2, 3. It's gonna count and it's watching time. Now it knows how many revolutions per minute the engine is running. The camshaft position sensor, which this one actually is, they look similar, has a few much less cutouts, but they are on the camshaft. That's why you'll see like your overhead cam, dual overhead cam engine will have 2 cam sensors, one for the intake, one for the exhaust, and they'll have a similar looking cutout on the camshaft. Now, the sensor will pick a different signal from the camshaft. It just needs to know where the position of the camshaft is. So that brings us to a very important thing, the correlation between the two. So the computer is watching the 2 signals from these sensors, and it basically takes these signals. By the way, I don't want to confuse you a lot with the signals, but here's how they look. This is just an oscilloscope a signal from them. Now, it takes those 2 signals and it puts them on top of each other. Once it knows where number 1 is and where the camshaft is, it's going to know where they are supposed to correlate. Now, that word, correlate, correlation, you're going to hear that word, and that's a scary word for car owners when they see a code with correlation. We'll talk about that in a bit. So it takes those 2 signals and puts them on top of each other. They should match 100%. When cylinder number 1 comes up, it wants to see that the camshaft is also at number 1. Or on the other stroke, it's going to know that. But if they don't match, if all of a sudden these signals that are supposed to be perfectly aligned are moved like this, it's going to know that. And it's going to set a code. Camshaft, crankshaft correlation. Meaning my camshaft and my crankshaft signals are not correlating. They're not on the same time. What does that mean? We're going to talk about it in the future, but I'll just give you a quick thing. The timing belt have jumped teeth. The timing chain is stretched. And then it goes into actually more stuff, which we will cover when we talk about variable valve timing. So here's a very important thing. These 2 inputs are vital to the engine starting. It cannot start with neither of them. And the crank position sensor is the most important one. So if you unplug your crank position sensor, the car won't start because the computer wouldn't know where the engine is at. It's just gonna look at it and like, okay, I don't know what's going on here. So it's not gonna start. It could start with 1 cam position sensor signal because it's gonna know, okay, my intake is here, so I know hopefully my exhaust is there. Of course, it's going to set codes, and it's not going to like it, and everything, but it could start. Once the engine starts, though, you could, in theory, unplug the cam sensor, and the engine will continue to run. You can unplug both of them, in the case of dual, and the engine will continue to run, because now it knows where the initial position is, and just going by this is going to make a calculation, because remember, the speed is different between the cam and the crank. So it's going to be able to sustain the engine running, but unplug the cam position sensor, it all goes down. Which leads us to one very, very important thing that I want you to know. If you have a code for a crank position sensor and your car runs perfectly fine, given what we learned right now, do you think we have a broken crank position sensor? Likely not the case, because if your engine is running, there's no problem with the crank position sensor. Now, it could be other issues, but a very common issue with Toyotas, when your battery is very low and you go crank that engine, the battery voltage will drop so low that it's actually going to affect the signal coming out of this guy. And then the computer will get this jagged signal that's all over the place because the voltage drops so low. It's actually going to think, in some cases, there's a problem, I don't like this, and it's going to throw that code. But the engine will start, After that slow crank speeds up a little bit, it's going to start. And it's going to be okay, but it already set the code because I don't like what I saw. And that's a very common misdiagnosis, especially on a 2GR FE. People go digging. I mean, the crank position sensor is buried behind the compressor. It's a nightmare on some of these cars to get to it. And after you get to it, you replace it, and you go about your way the next day. That same low battery is still there. You crank the car, the code's back. That's not a good situation. Folks, Toyotas, you will rarely get a cam position sensor problem or a crank position sensor problem. I'm almost to a point where I'll say almost never, unless there's a wiring problem, or this is another one. These wheels, and some of the older, now this wheel is from a 2AZ FE. Do you notice how it has the letter F? That means front. Now, do you want to take a wild guess what happens? So this, when you install on the engine, this faces you. This faces the front of the engine. So when you install it, this goes like this on the engine. Now, would you take a second to imagine if a mechanic or somebody doing a job, timing cover, or whatever the case may be, takes this and flips it? Now the signal is all over the place. Now, the engine will crank for a very long time because the computer will be looking at the signals. They don't match. I see the signal, but I don't understand it because it's all over the place. It's backwards. So it's going to start, but then it's going to run in an odd way, and then it's going to throw codes. And it's like, whoa, wait a second. My cam position sensor is not even in the same planet as my crank position sensor because, remember, this is now reading backwards. So it's going to throw a bunch of codes. On the newer style ones, though, they figured this was probably not the best idea. And then, by the way, most Toyotas, up until recently, they used to have the crank position sensor on the front of the engine. Starting with the 2GR FKS, and namely the 16 Tacoma was, I believe, the first one. Actually, the V8 was the first one. Don't quote me on that. Recently, the crank position sensor moved all the way to the back of the engine. So this guy, this gear, the gear with the teeth, is now between the flex plate, or most people call it flywheels for a manual transmission, and the back of the crank where the rear main seal is. That's where that guy is, and in the back you'll see the sensor going on the block. On the older ones, it was always in the front of the engine. The cam position sensors will always be where the cams are. It's usually right on top of the valve cover. Some of the old timing belt engines, they had them in different positions. Let's talk about air intake for the engine. So every gasoline engine, we've covered this briefly in the first part of this series. Every engine is going to need air, gasoline, compression, and everything to be done in time for it to run. Let's cover air. Now, engines create vacuum and they take air in to go with the mixture so we can make our stoichiometric happy in 14.7 to 1 and all this happy stuff. Well, how does a computer know? It needs to know how much air is coming in for it to know how much fuel do I put in with it. So the way it knows that is something that everybody knows what it's called, the mass airflow sensor. Looks like that, usually on top of your air filter box. Has two screws, one connector, people clean it, but they don't exactly know how it works or what it does or why are they cleaning it, and what does a computer do with this guy? How does it calculate? So let's talk about it. So air passes through the air filter into the air intake hose, that hose that goes from the air filter housing to the throttle body, and then it goes in the engine. We'll talk about throttle body in another video, but today I want you to pay attention to this, the mass airflow. Before we get into the mass airflow, the computer, I want you to imagine the computer decision making is based on data that it gets from all these sensors. There's inputs and there's outputs. the computer cannot see what the mechanical stuff are doing. It cannot know how much air is coming in. It cannot know what the fuel pump is doing, how much pressure it's making. It cannot know where the piston is at. It cannot know. It needs all these inputs, all these sensors to tell it, hey, this is what the mechanical parts are doing. Here's where everything is at. So then the computer would have this giant meeting with all the department heads, if you would, and then as you are stopped by the drive-thru of McDonald's waiting for your order, there is a whole operation going on in the background in the car, deciding all these things. Every time you touch the throttle a little bit, stop, it makes so many decisions in split seconds because of these constant input sensors giving input to the computer. Hey, here's what's going on. And then the computer looking at all this data, analyzing it, making the best decisions, and then outputs, commands, other actuators and injectors and all these parts that we're covering in this series, how to work, what to do, and when to do it. The first one is the mass airflow. And it's important that you identify what's an input and what's an output. This will help you in diagnosis. Now, we talked about the camshaft and crankshaft position sensors. These are inputs. There is nothing that the computer will do to command them to do something. They're just inputs, just to let the computer know where the crankshaft is and where the camshaft is. The mass airflow is the same thing. It is an input. It just tells the computer how much air is going in the engine. Toyota had mainly two styles of mass airflows. It had the door style, which you will not see anything OBD2 have it. This was very early 90s, mostly 80s. We're not going to talk about that. I made this series for modern cars. Everything you'll see today will have a mass airflow that looks exactly like this. They haven't really changed much. Maybe the size, the shape, but they work exactly the same. And let's talk about how that works. So the mass airflow has a small heater element. Let's think of it as a heater, like a little electric heater. And the computer is watching the resistance of that heater. As the air passes by, it's going to cool that heater. And the computer is watching how much cooling effect is happening on this heater. The more air passes across it, the more cooled this heater element will be. And it knows how much air is passing across it. Very simple, but it works very effectively. And the computer takes this variance in the draw of the mass airflow of how much is getting cooled, and it does a little calculation and it comes up with a number. This is how much volume of air is passing through into the engine. Now, all mass airflows on Toyotas this style, we're also going to have an air temperature sensor built into this guy. Now, the air temperature, of course, hot air will have a different density of oxygen than cold air. So it needs to know the temperature. And again, the temperature is also an input. Now, the computer cannot command this to do anything other than just the data that it's giving the computer. So again, this is an input. Now, mass airflows, you'll hear people cleaning them, people servicing them, or just flat replace them. After all, let's replace them every 100,000 miles. The reason you clean and what you are cleaning here is that heater element. Now, this doesn't happen all the time. People do it anyways, but the computer has a way of, now in the modern cars, let's say 07 and up, it has a way of knowing when this guy is getting a little dirty and it actually compensate for it. Because the air volume doesn't change. And when all of a sudden the computer sees, well, nothing have changed, but now my numbers are slowly dropping, it's going to compensate for that. It's going to know that this guy is getting a little dirty and it's going to compensate for it. However, cleaning it is not something I don't recommend, but you got to be careful because this heater element is a little delicate. And the idea here is, now in the olden days, and I say olden days, not really that olden days, I'll give you an example of the ones that got affected when this got dirty. 2001 to 2007, the MZ engine in a Highlander. When the element gets dirty on these models, and actually other models with the same engine, it gave a false reading. It started reading, it didn't know that there is as much air passing through here, and now it sets either lean or rich codes, and now it doesn't know what's going on because now the mixture is not right, because this vital sensor, again, vital sensor here, is not reading correctly. Now what happens if you unplug the mass airflow? The car will actually start, and the way it's going to start is the computer will work off of a pre-calculated number. Okay, at this RPM, I'm going to assume that I'm getting this much air, and at this RPM, but if you're in altitude, like if you're in Colorado, this is going to throw everything off. It's going to try to compensate for that altitude, but it's not going to be peak performance. It's going to fail emissions. It's going to basically go in a fixed matter. It's not going to be variable anymore where it can have that precision control over everything. Let's talk about another two terms that are very important for you to know from a diagnosis standpoint: metered air and unmetered air. Now, anything before air hits the mass airflow, like in the air box where the air filter is, that's not a metered area. Once the air passes across the mass airflow and gets measured, that is now metered air. So from the mass airflow all the way to the intake and the engine, that needs to be sealed. That needs to be 100% sealed. Any leak in that area, which is commonly referred to as a vacuum leak, now what's happening is I'm measuring, let's say, 10. Let's take a number. Let's make it simple. Remember, complicated, simple but complicated. 10. This guy is measuring 10. And the engine is actually receiving 15 because you have a leak between where this sensor is and the engine. So the engine is sucking air from the outside through this leak that didn't count here. So now it has more air than it thinks it does. And now that throws everything. Now the computer goes like, okay, well, I'm getting 10, but other sensors are telling me otherwise. So it just throws codes and it doesn't like it, and okay, we're not happy. Look, computers are very smart, but they don't think like a human brain. They're only as good as how they're programmed. When it sees that situation, it tries to compensate, gets to a point where like, okay, this is out of my control, I'm done. Here's a check engine light, and figure it out, mechanic. That's how computers are. So it is very important that we understand that any vacuum leak before the mass airflow in the air box side is not going to affect the computer calculation for how much air is coming in. But anything between the mass airflow and the intake valves, if you would, is gonna. So a broken vacuum hose that is after, a broken intake hose, a cracked intake manifold, a leaking intake manifold gasket, all of these will cause unmetered air to enter, air that was not accounted for to enter. So folks, now we've talked about a few of these sensors. I want you to think about them. I want you to take this information again and process it, if you would, because we're only starting here with this. There are so many sensors that we're going to talk about, and briefly how they work, and then more importantly, diagnosis. So now we know if you have a crank position sensor code and your car starts, likely we either have something else causing this code, like a weak battery, or perhaps this was placed backwards, maybe. But if the car runs, we're not going to go running to replace the sensor. We need to look at it. That's why I will say this in this video, and you'll hear me say this a lot throughout this series. Just because you have a code that says the word apart, like let's say it says mass airflow, or it says a cam position sensor, don't just run and replace that part. There needs to be an understanding of how these systems work so you can effectively do a diagnosis. Some of these parts will fail, and that's okay, but you need to verify that. We can't just jump and replace parts, because otherwise, why is there a guy like me who diagnoses cars if the code tells you what what the car needs. Just replace this part and move on. Then we don't need mechanics anymore. We just need part replacement, guys. And that's not the case. That's not the case. When you have a code for the mass airflow, most of the time when there's a giant, big enough vacuum leak and it sees that this signal is completely wrong, it's going to set a code for the mass airflow. But actually there's a vacuum leak. Think about that until the next part of this video, where we're going to start talking about fuel system. I hope this video was helpful and informative. I hope you learned something new. If you like this video, consider giving it a thumbs up. If you're not a subscriber, consider subscribing to the channel. Check out some of my other videos. And until the next part, guys, may the Lord bless you and keep you, and you have a wonderful day.